Yeah, so I was saying I'm the one between the end of the event and the beer. And I'm, as you, probably very tired by the event because there have been a lot of sessions. So my goal here is to make a point around the Redfish standard. And how many of you have heard about Redfish? Using it? Okay, great. So my name is Bruno Cornec. I'm working for a hardware manufacturer company, which I will not necessarily name here because I'm on my own for the travel. So you will guess during the slides. I've been involved in various open source projects in the last 25 years, and I'm interested in Redfish around the Python project that we have been doing in a small team of people. First, I would like to just to remind some definitions around what we are dealing with. So everybody is aware of what a REST API is? Yes? Okay. An API? It's clear? It could not be just REST, it could be POSIX, it could be Xwindow, it could be whatever library defines an interface between two environments. JSON is clear for everybody as well, I guess? Yes. Structured format, great. OData? Okay, so this is something Microsoft has come with as a protocol to enable the creation and consumption of REST API. I'm not a huge specialist of OData, but it's used in combination with the rest of the other three protocols to create Redfish. So Redfish is an open industry standard, which is providing specifications, schema, and a set of tools these days to help you with regards to machine management, I would say. It started on the server side, and the goal is to, if you are familiar with the notion of BMC, so an onboard chip on your machine, which allows you to do, which is completely separated from your operating system, your operating environment, which gives you access through a network port to another operating system running there and giving you information and ways to manage your server out of band. So this is what the BMC is doing, and there have been a lot of standards in the past to try to help you manage at scale a fleet of servers. And typically you used to have something called Smash, for example, which was a command line interface tool created by the DMTF, the same guy who are creating Redfish. And Redfish is there because Smash did not really succeed. With aware of Smash in the room? Okay, one. Was used Smash in the room? Okay, so that's why. So it was pretty complex. It was really not standardized across vendors. So it was really difficult to deal with, and you had to learn a new interface each time you were changing from hardware manufacturer, which was not really nice. So that's not one of the goals of Redfish. Redfish is really there to help different manufacturers to agree on a hardware representation of your machine and an API sustaining that hardware representation so that you can have access to the same hardware components in different manufacturer servers the same way. So it's using, as we were mentioning earlier, it's a RESTful API. It's based on JSON, and it's also using OData for some representation. The goal is to have a much better hardware support than what was provided before. So the ancestor, I would say, of Redfish was IPMI, which had a certain number of drawbacks. Especially it was not really secure, it was pretty cumbersome to use, and it did not provide a lot of hardware information on complex hardware setup. Complex hardware setup could be a blade system with chassis where you want to address multiple servers inside a single enclosure, having a single management interface, or multi-node platforms. So one manufacturer I know of, which is HPE, has a machine called Moonshot, in which you have cartridges which can have embedded management board as well as a chassis management board, and each cartridge can have multiple CPUs, multiple systems on it. So the Redfish standard was created to support all type of hardware design, not just a standard server, 2 processors, RAM, memory disk, NIC, etc., etc. The goal is really to be able to have a model which is suitable for more complex platform. And you may know that some manufacturers are working on memory-centric type of computing these days, and we will have in a couple of years we will have machines which will be made of pool of memory somewhere, pool of compute in other places, CPUs, different type of CPUs, and very high-speed interconnect between the CPUs and the memories and the disks, if there are disks, or pool of very large pool of memories. And so the Redfish standard should be able to support those new type of design of systems that will happen in the coming years. So it really has been architected that way. Of course, when you gather, I don't know, 10 different hardware manufacturers around the table, and you say to them, okay, let's talk and make a standard, it's pretty difficult. Each one wants to have the best support for its own hardware servers, hardware platforms. So the standard evolved slowly because they really agreed on a subset, which was pretty small at the start, of certain number of features that you have in a machine, and everybody was in agreement on how those features should be described and should be accessed. And as time passes, they were adding more and more features so that more complex architecture were recognized and in common between different manufacturers. However, you always have some, so the marketing departments in our company calls that added value, and sometimes you can call that crap, but that depends on your point of view. But anyway, a lot of hardware manufacturers have some features that are not standardized because it's something which differentiates them from another hardware manufacturer. But they still want to be able to access to it. So the best example in history is probably SNMP. SNMP was working like that. You had the standard MIB, and you had public information with the OIDs, and you were able to access to certain number of information completely in a standard way from one manufacturer to another. But for example, our fans in our servers were accessed in what we call a private MIB. So we had a sub number under which all the tree was our IP and was described, and you give access to the people to the information, but that information for the fan was different from a server from Dell, a server from Lenovo, a server from someone else, Huawei or whatever. So really, Redfish had to propose the same type of mechanism, and they created the notion of OEM schema to be able for manufacturers to store some information that are their own information that they are not in agreement to standardize yet. Either because not all the manufacturers have the same feature, and so the other don't want to expose in a standard something they don't have, because that would put them at a disadvantage, or because it's something that the other don't have not developed or not interested in, and you want to keep it on your side. So hopefully after the FOSDEM there will be a Redfish page, because I was supposed to make that slide based on Wikipedia as the previous page, because I think it's a very good source of information, but there is no Wikipedia page for Redfish yet. So I've written what I had in mind on one template, and I will propose that when I'm in the train back to my country, and hopefully next week we will have a Redfish page which will explain a bit what I explained to you here. So the standard is not completely new. It's a 4 years old standard which has been published originally. So mostly what you had were the JSON and the OData schemas to describe the resources which are available, and a very light mock-up was made to allow developers to test Redfish even if they didn't have access to a hardware-supported Redfish implementation. Because when we started, the standard was there, but there were very few hardware manufacturers who had added that feature in their BMC. Nowadays, it's very different. There are a lot of manufacturers which are providing support for Redfish with minimum firmware version depending on the manufacturers. I put here some of the major ones in terms of numbers of servers sold. Feel free to, so I also put that in the Wikipedia page. Feel free to add if you are dealing with a manufacturer you know that is supporting Redfish, feel free to add to the information. So you have mockups, you have real hardware, you can play with it. That's pretty interesting. A lot of documentation has been published, as well as white paper, facts, etc., on this URL, so the dmtf.org website, under the standards, that standards area. They have a Redfish entry point in which you will find all this information, and you can download all of that. So latest version is 2018.3, which has been published in 2019. Don't ask me why it's not on 19.1. I don't know. That's the way it is. So there have been, I think, 7 or 8 revisions of the standard still since the beginning. You have release notes, which each time describe what has been changed between the latest version of the standard and the newer version of the standard. Since the 1.0 version originally, it's mostly addition. So there has not been any big change in the way the standard has been designed compared to 0.99, where it was a bit different. Okay, so what can you do with Redfish? So typically you can do what you do with APMI historically, so you can have a lot of information about server health, temperature, fans, identification, asset information typically, and inventory on the hardware platform, as much as your BMC is able to provide to you. There are about something like 400 items that you can get, and among those 400 items, 25% are items you can modify through Redfish as well, because you have the you use the REST API interface, so you can get information, but you can also post information to the Redfish API and have configuration items modified on the fly. You also have actions that you can pass on the server around power management, around the boot order, around some thresholds for the power, around alerting and logs. And you can also deal with the BMC itself, with its network settings and the user accounts for authentication on the system through the BMC. So DMTF is providing quite a large set of tools to deal with, as examples, I would say, on how to deal with the Redfish interface, so that you can take that software as a reference point and include that either in your programming environment. So mostly what they're providing is C bindings and Python bindings. There are some CLI tools, and there are more and more tools available. Not all of them are working for all of the Redfish implementation. So I don't take part here, but I'm trying to make some of those tools work on my HPE reference hardware, and as those have been developed by Dell, sometimes there are some differences in the way you interact with Redfish, and especially the setup. The access to the /Redfish/v1 interface is a bit different, but globally, once you have passed that hurdle, the rest is working really, really fine. So you have the possibility to do simulators. You can, for example, if you have a real hardware server, you can capture the Redfish implementation of that server and put it in a simulator, and then run it as a software appliance. So it's pretty interesting if you want to do tests without having access to the hardware. Which is also nice when we were speaking about kernel CI and the possibility to do automatic testing. That's one of the features which is pretty interesting. What else? So personally, with a group of people, we started the Python Redfish initiative. I have another slide on that. A couple of years ago, I've been ill last year, so I've not been able to work on it. Hopefully, I will restart that this year. The OpenStack guy didn't want to wait till we fix some of the issues he identified, so they created another Python library called Sushi. There is also another Python library on the Redfish DMTF, so everybody is in love with Python these days. I'm missing my Perl bindings. That's why there is a comma here, and I need to do something for that. But there is no reason. I mean, it's just REST API, so it's easy to do bindings in other languages, such as Go or Perl, whatever language you like. The only major application which has yet already a Redfish driver is probably the OpenStack Ironic bare metal deployment project. I don't know of any other tool which has integrated a Redfish support to do automatic inventory or automatic deployment, for example, based on the type of systems that you could have. You can have a lot of ideas using this type of tools. I will go into it. So the data model looks like this one, but I won't pass too much time on it. What I will do is more go on to directly the live one. So bear with me 1 second. So I will just explore the markup for a simple rack-mounted server. So this is on the DMTF, directly the DMTF website. They are not answering very quickly. So they provide a certain number of markup for simple rack-mounted servers or OCP machines. They have blade systems. Okay, interesting. And so when you explore the data model, it looks like that. So you have your entry points, which are, so these are the OData stuff. I don't know why we are in need, I need to discuss with the guy because I don't really understand why we are in need of that instead of just plain JSON. And you can have fields directly, and you can have, of course, collections available. So here we have a single system, but you can have the notion of chassis. So for example, if you go on the blade here, you would have more stuff. You have the manager, which corresponds to the BMC. So for example, if you look at the manager, you have just one BMC on the server. And if you go on the BMC, so this one is not a real physical server, it's just a fact one to show what type of fields you can get. And you will see that you have, for example, the NIC itself of the BMC that you can query. And finally, when you have parsed the tree enough, you can find the MAC addresses, for example, of the BMC. So if you want to do the HTTP configuration, so not for the BMC because you need to have access to the BMC first. So that's not really the most useful part. But if you go on the system side, of course, and you have just one system, you will find exactly the same type of information for the embedded NICs inside the system. So for example, you see you have a TPM 1.2 component inside that servers. You have a certain number of information on the naming, on the asset number, on the BIOS version, which can help you derive an upgrade strategy if you have a fleet of servers and you want all the servers to have the same firmware version. That's the type of stuff you can do with it. And again, you can parse the BIOS, the processors, memory, internet interfaces. So here I have two NICs in my server, and again, I have my MAC addresses, IP addresses here in that case. So the MAC address, a hardware MAC address, so you can have a fake MAC address, you can have a physical one, and you can override the physical one by another one if you want. So here is the way to parse the information, and all that is accessible through the REST API. So here it's just a nice looking visualization system for it. Okay, let me just go back. So for those of you who are fan of Python, there is a work we've done around Python Redfish with a couple of people initially around OpenStack. We use Python request Tortilla to map, in fact, the data model of Redfish in memory and being able to parse it very, very easily. Our goal, and that's still a work in progress, we have a markup for that, but it would require a bit more development. The interest for me of Redfish is really around activities. So I'm part of Solution Center. We host 400 servers. We do models for different type of customers. And we are rebuilding the data center all the time. We move servers, we move parts in the servers because we have to build something which corresponds to the customer request. And the idea is to say, okay, how can we automate the management of those changes in relationship with our CMDB? So we have a CMDB. But each time you change a RAM from one server to another, your CMDB is wrong, except if you do manually the operation inside the CMDB, which is very time-consuming and a stupid job. So the idea is to really use, well, it's not stupid for the people doing it, but it's you can use your time in a better way and drink beers at FOSDEM, for example. But so the idea is really to say, okay, if I could create my hardware platform so that this part of the inventory is always up to date and pushed into my CMDB, that would be great. So what we want to do is have a data model for our servers in the data center, which are looking like the Redfish one, because we don't want to reinvent anything. And we want to map that data model to the CMDB data model we have. And the CMDB we are using is an open source one called ITOP. And so the data model of item is a parameter. So you can change the data model the way you want. So we can very easily map the two data models. And each time we modify something on the hardware side, pull information through Redfish call into the CMDB. And the CMDB is working by erasing information which have changed, but keeping all the rest of the information which have not changed. So it's pretty easy to use, and that would allow us really to improve the time that the people pass on maintaining that CMDB and just maintain the information that only humans can maintain, not machines. So that's one of the area where Redfish could be very useful, in my opinion. Another area could be on the deployment. So if there are Red Hat people in the room, for Anaconda, for example, on RHEL, you could have a look at Redfish to try to grab hardware information from the Redfish schema and detect automatically a certain number of hardware information that leads to device names or hardware setups that could be easier to do using Redfish directly in a portable way. The interesting part is that you do the Redfish call, and whatever the nature of the server you get, then normally you should have something which drives a decision which could be the same for all manufacturers. So that's really the type of ideas you can have around that. So if you want, it's on pip. If you want to look at it, that's one version available. You can also look at the DMTF stuff as well. I'm working on the mock-up to automate the test of our client with regards to the DMTF mock-up so that it works correctly. Any question? Yes, you're first.
So what is CMDB?
Oh, sorry. CMDB is a configuration management database. So this is a place where you are managing your assets in your IT infrastructure, which could be not just computers, it could be copiers, it could be phones, it could be buildings, it could be whatever you want. In the CMDB we have, you can also manage, for example, service level agreements, providers, point of contacts, etc. And you can have a measure of impact. So for example, imagine you unplug a power cord in your data center because you need to do electrical maintenance on an area. You can say, okay, just CMDB, tell me if I unplug that, what is the impact on my infrastructure? So what will be the services at the end which are touched if I remove a plug on my wall? So that's the type of service a good CMDB is able to give to you. And the more the CMDB is up to date, the more precious it is for managing your environment. And the more automation you can put in it, the best it is, because if that information is correct, it's coming directly from the hardware. You had one question?
Yes. What about security? IPMIs are very problematic if they put on a public internet. And the problem is you cannot expect you are expecting your client, somebody who has bought that server, not to put that on the internet, but they sometimes do.
Okay, so with regards to security, customers should never put a BMC on the internet. That's clear?
Of course, but they do.
Change customer. I mean, teach to your customer. Teach to your customers is really a bad idea.
Yes, it is, but you can find millions of IPMIs open online.
And it will not improve with IoT devices, which are also sometimes on the internet and are sort of BMC somewhere. I understand. The Redfish protocol is HTTPS.
Okay.
So you need an authentication mechanism to be able to log onto the system. So it's as secure as your authentication schema is.
Okay, but usually that IPMIs and IPMIs and BIOS is never update. Usually you should never update that.
So the problem, as you mentioned, is an update, for example, update of version of BMC firmware, and that's true, and that's, I mean, the BMC should be managed like a standard system, so people should pass their update on a regular basis. They should automate that if possible. They should, I mean, that's part of the CI environment for managing. It's as an operating system, you are upgrading your operating system. You have a workflow, you have a approval for upgrade, you have tests, etc. You should do exactly the same for management of the BMCs on your servers, because that's as critical as the rest, even if it's not on the internet.
Some vendor doesn't maintain it, and some of them are using old technology like Flash and stuff like that, and after they're not maintaining. On top of that, usually the BMC can be configured to be shared on the first LAN, the first NIC. This can be dangerous as well, because they can even be aware that the first NIC will take from the DHCP an IP that might be public as well.
Yeah, so the comment is that there are problems with the software implementation on BMC, so the software stack used on BMC, the fact that it becomes obsolete, and the fact that it could be shared with the first NIC of the server, the access to the BMC. I would say make tests with your hardware manufacturer before buying the hardware, and include tests on the BMC as part of your evaluation of the platform. There are good providers that don't do that anymore. That may used to do that in the past, but don't do that anymore. But I agree. It's, I mean, Redfish has not a goal to solve those security issues per se. It's a way to do secure management because it's encrypted and it has an authentication mechanism compared to IPMI, which was really poor, or SNMP, which has also a certain number of other problems. So it does not solve the hunger in the world, but it solves some of the problem.